Section 4.5, Newton's third law of motion. This is the final law that we'll begin to look at. It says whenever one body exerts a force on a second body, the second body exerts an oppositely directed force of equal magnitude on the first body. This one in more everyday terms, you may have heard said as for every action, there's an equal and opposite reaction, where the action is a force, the reaction is a force of the same magnitude in the opposite direction, right? And so this is something that is all around us, but we often take for granted. For instance, if I hit the wall, it turns out the wall is actually hitting back. If the wall wasn't pushing back when I push on the wall, then my hand would just pass right through it. But instead, when I push on the wall pushes back on me and I can feel the wall there. And the amount that the wall pushes back on me is going to be proportional to the amount that I push on the wall. So if I just barely lightly tap on the wall, I don't feel it too much, right? It's not exerting a large force on me. But if I hit the wall with a lot of force, it hits back. That's not very nice, right? But it hits back with the amount of force that I hit it. It's entirely equal and opposite. So you can try it out yourself. Please do not hurt yourself because walls do hit back. But this is something to keep in mind whenever you have forces. So if you push on something, something else is going to be pushing back on you. There's always pushback. Right, so here's an example where it perhaps is easier to see. Suppose we have an astronaut in space outside of their spacecraft, and they push on the spacecraft with this force P. Well, by Newton's third law, that means the spacecraft is pushing back on them with the same magnitude of force, but in the opposite direction. So that's what this negative P is the amount of force that the astronaut feels from the spacecraft pushing back on them. And so if the magnitude of P is 36 newtons, and the mass of the spacecraft is 11,000 kilograms, and the mass of the astronaut is 92 kilograms, what are the accelerations? What are the accelerations? But the astronaut's the only one doing the pushing, right? Well, if you think about a massive spacecraft, and if you push on the spacecraft, the astronaut's going to start moving, right? So she might be in trouble right now. Hopefully she's hooked in if she's going to be pushing off of it. But we can figure out the accelerations here. So let's take a look. So on the spacecraft, the sum of the forces is just the pushing force P of the astronaut. The astronaut feels the reaction force of the spacecraft, this negative P force. So the acceleration of the spacecraft is P divided by the mass. So 36 newtons in the positive direction divided by 11,000 kilograms comes out to 0.0033 meters per second squared. Versus the astronaut feels a net force that's equal to minus P divided by the mass of the astronaut. So negative 36 newtons divided by 92 kilograms comes out to negative 0.39 meters per second squared. So notice first the acceleration of the astronaut is in the negative direction because in pushing in the positive direction, she's then going to move in the negative direction, the opposite direction. Notice also the relative magnitude of these two accelerations. The astronaut feels an acceleration that is 100 times bigger than that of the spaceship. And that's why it looks like the astronaut's the only one moving, right? That the astronaut has just pushed off the spaceship and is flying away from it. It turns out the spaceship also has been accelerated and is moving in the opposite direction, just with a much lower acceleration. So this is an interesting detail here, that when the astronaut pushes on the spaceship, there's an equal amount of force acting on either object, on the spaceship or on the astronaut. Why is there such a different result? Well, the different result comes from the difference in mass. The astronaut is tiny compared to the mass of the spaceship. Since the spaceship is so massive, it experiences very little acceleration with the same amount of force applied. The astronaut, meanwhile, has the same amount of force with much less mass, and thus has a larger amount of acceleration. So there we see Newton's third law of motion, or every action has an equal and opposite reaction.